In this video presentation, I'm going to talk about Polyphloisboisterous 030, my compact accelerator card for Apple's Macintosh Plus. I will lay out a brief history of the upgrades that came before it, and why I decided to create my own. Manufactured from 1986 to 1990, the Macintosh Plus superseded Apple's previous two Macintosh models with a built-in SCSI port, double-sided 800KB floppy diskette drive, and support for up to 4 MB of RAM. It sported a Motorola 6800 microprocessor clocked at approximately 8 MHz, just like its predecessors. Over the years, several companies sold accelerator upgrade cards that could improve the performance of an early Macintosh computer by replacing the main microprocessor. In 1987, Novy Systems of Edgewater, Florida began selling a line of Motorola 68020 accelerators for several Macintosh models. The Macintosh's 6800 microprocessor would be supplanted by the higher performance 68020 on the card. As you can see, there are accommodations for an optional Motorola 68881 or 68882 floating point coprocessor. The low-end Novy Mac20 only clocked the CPU and FPU at 8 MHz, while the higher-end Mac20MX could clock up to 24 MHz, and added SIM sockets for 32-bit RAM along with an expansion header for optional fast SCSI and external monitor upgrades. Quite a few discrete integrated circuits are employed in this design. Most of this logic is for dynamically slowing certain operations performed by the 68020, so it may conform to the Macintosh's 6800 bus. Novy's accelerators were later licensed to third parties and sold under brands like Daystar, Mac Products, Total Systems, and Extreme Systems. In 1990, the cards were updated with Motorola's 68030 microprocessor and rebranded as the Novy Quick 30. Again, these were sold under many other brands. Around this time, two companies called Quest Computer and Engineering Solutions designed a card called the Total Systems Mercury 030. It was sold by the Novy licensee we all know and love as Total Systems Integration. All the discrete digital logic that the Novy cards used is now condensed into 4 programmable generic array logic or GAL chips. The 68030 CPU is clocked at 16 MHz, but there's an option to clock the FPU at higher speeds using a separate crystal oscillator. There are 2 expansion headers, one for an optional 32-bit RAM expansion card and another for a fast 1.2 MB per second SCSI upgrade. By 1994, it appears a new company called MicroMac Technology has swallowed all their competitors. They now sell an accelerator called the MicroMac Performer, which is essentially a Mercury 030 that has been beaten into a brand new shape. The expansion headers for RAM and a SCSI card have been removed, and there's a new footprint for the accelerator to be installed in a Macintosh Classic. A 5th GAL has been added to double the 8 MHz clock to 16 MHz, so it's no longer necessary to tap that high-frequency clock from elsewhere on the Macintosh logic board. All in all though, these vintage upgrades are extremely rare. So, 24 years later, in 2018, 68K MLA4 members Trash80 to HP Mini and Bolle began reverse engineering the MicroMac Performer and Mercury 030. In 2022, Bolle published the design files for a reproduction Performer circuit board, along with schematics and JEDEC fuse maps of the 5 GALs. Now, hobbyists have all the ingredients to build clones of the MicroMac Performer. I myself was looking to build one of these clones for my Macintosh Plus, but I didn't want to pay a $24 engineering fee to order 5 boards through JLC PCB. I would also have a hard time surface mount soldering the GALs without a hot air gun or hot plate. I thought the Performer board was too complicated and had several footprints that were not going to be populated for installation in a Macintosh Plus. I found a GitHub repository where someone had already converted the Performer board files to a KiCad project, so, I went to work laying out my first printed circuit board with no prior experience. I wanted my accelerator to be as small as possible and to only have the bare minimum needed for operation in a Macintosh Plus. I decided to remove the FPU socket as the classic Macintosh system software rarely uses it anyways. I also changed the surface mount pads used for the GALs to PLCC socket through holes, which meant I could actually assemble this board by hand with my $25 soldering iron. The signal traces were auto-routed by KiCad's free routing plugin, then manually corrected by me. The resulting board is 50% smaller and 77% cheaper to manufacture over the original Performer. I called it Polyphloisboisterous 030 as that's a freakishly twisted portmanteau of Greek and English words used to describe something that is loud roaring, and also because I like to mess with people. I drew up a cuddly mascot to symbolize 68K Macintoshin. The next step, I ordered my first batch of 5 PCBs through GLC PCB, and 2 weeks later they arrived at my home from Shenzhen, China. I also ordered PCBs for Afterburner, a gal chip programmer for Arduino. I assembled an Afterburner, and after getting that all fixed and such, I used it to program the 5 gals needed. After soldering a socket to the Macintosh's 6800 CPU and stacking an assembled Polyphloisboisterous 030 on top, everything worked as it should on the first try. The Macintosh booted System 6.0.8 from my Blue SCSI disk emulator, and the 16 MHz 60030 was detected by the MicroMac Performer driver. I immediately noticed an increase in speed even when simply navigating the Finder. These benchmarks from Speedometer 3.23 show a 270% increase in performance for CPU-related tasks, and even 139% faster SCSI disk speeds. Here's an alternate visualization of the overall performance improvement. I was able to boot System 7.1, but a lot of the applications I tried to launch crashed immediately. Turns out the Universal Gemstart 7.1 drivers needed to run System 7.1 reliably. And if there's a tricky program that refuses to cooperate, it's possible to temporarily disable the accelerator by pressing a special combination of buttons on the programmer switch. While this upgrade does make things speedy, it is bottlenecked by the lack of external cache memory, the logic board's 8-bit wide data path to RAM, and the Macintosh Plus ROM, which is missing many functions that were later added into the ROMs of native 68020 and 68030 Macintosh computers. This last kerfuffle is the reason why not every Macintosh program requiring a 68030 will work with this accelerator, as programmers assumed any Mac with that CPU would also have certain routines in the newer ROMs. In the case of the higher-end Novy cards and the Mercury 030, it was possible to alleviate the narrow system RAM bandwidth by attaching 32-bit RAM, although it seems the Macintosh would still have to switch to its system RAM about every 1/16th of a second or so to read or write to the screen. The Mercury 030's RAM card has already been reverse engineered by Bolle, so it's entirely possible to integrate it into a new accelerator card design. Such a card could use a single 4MB 72-pin SIM for memory, as that's the maximum amount the Mercury 030's logic can address. At this moment, Builder 68 of 68K MLA forums is experimenting with this. Now, the question we've all been waiting for. How useful is the 68030 upgrade for the Macintosh Plus? Well, it speeds up everything you can do on the computer, and that's about it. In my limited testing, I've not yet found a program that explicitly couldn't run on a stock Macintosh Plus, but that did with the accelerator. No, this accelerator is not going to allow you to run Netscape 2.02. ROM limitations are a big factor here. The faster 68030 also causes audio distortion for some applications, but, at least using the Macintosh becomes less of a chore, right? Everything you do is faster, right? Designing and assembling my own custom PCB was a fun and rewarding experience for me, really, but come on, believe me. I saved money by rolling my own instead of ordering stock Performer PCBs. I learned a lot about electronics and sold my remaining PCBs to other hobbyists. The design files, documentation, bill of materials, all that stuff for Polyphloisboisterous R30, it's all available on my GitHub under a Creative Commons Attribution Non-Commercial Share-alike license. Thank you for watching my video.